Hello everybody, my name is Evan Wojtolski and welcome to Tideline, Swede's first and only American-style covered call options protocol. When you first come to the website, connect your wallet, choose between light or dark mode, and grab yourself some test tokens from the faucet. You don't even need any test SWE in your wallet because we have a gas station that strictly allows front-end only transactions. This is our earn page. We have a number of assets that you can select from, as well as expiries. You choose the strike that you want to sell your covered call option at, and you get a premium quote right back. I want to draw your attention to this queue. Exercises happen in first come, first serve order. So this cursor shows the number of options that have been exercised up until this point, and this bar down here shows where you would sit if you wrote this option. Before we move on, I want to show you exactly how this quoting process works. This earn flow works through an RFQ process. Our front end sends an RFQ through our backend quoting service, which propagates it to all of our connected market makers who respond with a signed quote that gets sent back to our front end. Our front end then takes this quote and submits it as a transaction on chain. My smart contracts then verify the market maker's signature, pull the premium from our market maker's account, take the Bitcoin out of our user's account, and submit it into the call option bucket pool. Then our call option gets minted as a token representation back to our market maker. And because it's a token representation, that means we can trade it on DeepBook. And this is the buy page. On the left, you can see our strike grid with the current strike price in relation to everything else. You've got your Greeks, your book details, the current book state, as well as any open orders that you might have. Let's go ahead and buy 0.1 of a Bitcoin option. Currently, our market maker bot is configured to just dump any inventory that it gets onto the book, and it only updates its prices about once a day. That's just to conserve testnet gas. We can also go ahead and purchase this straight from the market makers through the same RFQ process in reverse. We are just asking them how much premium they want in exchange for an option token. This costs about the same $11. Now we can go over to our dashboard and see all of our open call options and positions. And here you can see we have the 0.02 of our call option that we just bought through both of our different mechanisms. If we exercised it right now, we would lose $2 because it takes into account the amount that we paid for the asset. We're going to exercise it anyway, just so I can show you that it works. We lose our money, we get some Bitcoin in return. And you can also see some of the calls that I've written for tests and the calls that we wrote earlier in the demo. So why are we doing traditional options? The big one is that it enables premium collection as a yield source. There's no other protocol that lets you capture this yield on SWE as an asset. Also, unlike perps and binary options, traditional options let you slice an asset's risks into separate components and take exposure to only the ones you want, like its deltas, its gammas, and its implied volatility. Further, if you're using options to bet on the direction of a market, you have a capped downside, and that's your premium. But let's talk about the yield source. So let's head over to the vault page. We've set up a mechanism that lets you deposit your underlying asset once and auto compound the premium. We have a series of SWE options running hourly right now just to demonstrate the life cycle of the vault, so we don't have to wait an entire week for that to happen. But here you go. Literally, all you have to do is deposit your SWE. It'll show up here for you to claim your shares. This is the old one from another round. I'll claim those right now, and the other ones will come up here shortly. We can also withdraw at the end of the rounds, or submit a request to withdraw for when the round ends. This is the life cycle of our vault. The keeper chooses a strike with a 10% probability of falling into the money. We use an on-chain RFQ process to sell the calls, and then we use an on-chain auction to sweep the USDC back into our underlying asset. We wait for expiry, sweep the funds back into the vault, and then close the round and repeat it. The last thing I want to show you is a hyper-experimental login mechanism that lets users bring a non-SWE wallet into my protocol. After they connect their wallet, a session cap object is minted to a SWE wallet running locally in their browser, acting as a session key, allowing the user to interact with the protocol as a first-class citizen, never having to interact with their wallet until it is time to withdraw. They're issued a SWE address and can connect or disconnect their wallet at any time. This is what our backend architecture looks like. We are 200,000 lines of code deep, and every single bit of it was built during this hackathon. Thank you. That's Tideline.